All right, your warm-up problems are taken pretty much directly from what we learned yesterday. Anyone know the answer for the first one? X to the 10th. Very good. When they each have their own base, you just add the exponents. What about on the next one? You got 1 over x to the 6th, y to the 5th. Very good. There is a middle step there. If you subtract them, you'd get x to the negative 6th, y to the negative 5th. Remember, negative exponents, you just take the reciprocal and make the exponent positive. So they would both go down to the bottom of a fraction. The exponents would become positive. You need a 1 on top as your placeholder. So you get 1 over x to the 6th, y to the 5th. Another way to think about it is how would they cancel? If you had 2 x's on top and 8 of them on the bottom, when you cancel out, you'd have 6 left over on the bottom. That's usually how I think of it. Same thing for the y's. Section 6.2, our objective is to evaluate polynomial functions. I'm going to show you 2 methods. One of them is very obvious and you'll probably all want to use. The other one's just kind of a neat math trick that I want to show you. And then we'll talk about just how to classify polynomials, how to write them in standard form. Probably stuff you already know. We are going to finish this section tomorrow talking about graphs of polynomials and how they behave when you get really, really big or really, really small. So by the end of class tomorrow, you should be able to do all the homework for 6.2. Today you'll get about halfway through it. So here's our first definition. What is a polynomial function? A polynomial function has this form. It looks pretty complicated, but it's not really that bad. The a sub n is just your coefficient in the front. N is your exponent. As you go down, the exponents get smaller and smaller and smaller until the end where you don't have an x term, you just have a constant. Here's a little more information. Whatever is in that spot is your lead coefficient. Whatever is your first or your biggest exponent is your degree of the polynomial, and whatever's on the end is your constant term. Here's some other important things to know. Your lead coefficient cannot be a 0. If it is, that whole term would be 0, so it would not be your leading term. It wouldn't be anything. All exponents have to be whole numbers. So for it to be considered a polynomial function, there can be no decimals or no fractions or no negatives in the exponent. Coefficients have to be real numbers. Remember, real numbers are pretty much all the numbers besides imaginary numbers. So fractions are fine, square roots are fine, irrational numbers like pi, those are fine. They just can't be imaginary numbers, so no i's. And you will have to write these in standard form. Standard form is when you write them from the biggest exponent to the littlest exponent. So you just have to rearrange some things. So the standard form column looks kind of intimidating. Remember, anytime you have an a sub 0, that's just a number. And then you have the x with it. So like on the second one, the a sub 1 x, that just means a number times x plus a constant. So don't get too intimidated by those. I would write this down. I would actually maybe just write these first 2 columns down. And maybe this example column. I'm not sure if this is kind of extra notation that I don't know if it's super meaningful right now to you. So I would probably do the degree column, the type, what we call it, and then an example. So the degree of 0, that means you don't have any x's, because x to the 0 is just 1. So you don't need to write the x's. It's just multiplying a number by 1. So when your degree is 0, it's just a constant term. Like I said, no variables. So an example of that would be f of x equals 7. Remember, the f of x is similar to the y here. So if we were going to graph this, this would just be the line y equals 7. If your biggest exponent is a 1, this is a linear function. We've looked at a lot of those. That's where you graph it and it's a line. Those are usually in the form y equals mx plus b or f of x equals mx plus b. As you see there, 2x minus 4. All right, if your biggest exponent is a 2, we call this a quadratic. That's what we did all last chapter. And you've seen a lot of these. They have an x squared term, an x term, and a constant. These are the graphs that form parabolas, your favorite. These next two are the newer ones. If we have a degree of 3, it's called a cubic. And it looks something like this. You'd have an x to the third term, an x squared term, an x term, and a constant. Sometimes you don't have all of them, as you guys know, but you'll need at least the x squared term for it to be considered a cubic. And then if the degree is 4, it's called a quartic. And it looks like that. So you have an x to the 4th term. Anything past that, you just usually say the degree. So if the degree was 5, you'd say a degree 5 polynomial or a degree 6 polynomial. What are your questions on this? This is just how we name them. All right, here are our first examples. So it says decide if each is a polynomial function. If so, write it in standard form. State the degree, state the type, state the leading coefficient. So remember, in order for this to be a polynomial function, you cannot have negatives in your exponent, you cannot have fractions in your exponent, you cannot have decimals in your exponent. So any of those things would eliminate it from being a polynomial function. So is a polynomial function?
No.
Do you have a fraction in the exponent?
No.
No. You have a fraction, it's not in the exponent. So the fraction's still fine. What do you think now? Is it a polynomial function? Yeah, the exponents are 2 and 4. That's completely fine. So yes, this is a polynomial function. When you write it in standard form, you go from biggest exponent to littlest exponent. So what term do I want in the front? Negative 3x to the 4th. Good. Then I want the x squared term. Then I want my constant on the end. The next thing we're looking for is the degree. The degree is just the largest exponent. So what's the largest exponent here? 4. The leading coefficient is your coefficient that's in the front when it's in standard form, or the coefficient with the term that has the largest exponent, so negative 3. And this is called a quartic because it has degree 4. What are your questions on this? All right, B, is that a polynomial function? Check out the exponents. Are they all whole numbers?
Yeah.
No, we don't know what x is, right? What if you plugged in I for x? We don't know. So you cannot have variables in the exponents. So the variable in the exponent right away eliminates that one. No. If it is not a polynomial function, you can't put it in standard form, you can't state the degree, you can't state the type, you can't do any of that stuff. So if the answer is no, it's just no. What about C? Is that a polynomial function? No. Here's why. No negatives. Oh, sorry. D, is that a polynomial function? Just check out the exponents. Are your exponents okay?
Yeah.
Yeah. Your exponents are a 1 and a 2. So yes, this is fine. Now we write it in standard form. So biggest exponent to littlest exponent. What goes in the front?
Pi.
Yeah, pi x squared, followed by the negative 0.5x and the minus square root 2. What is the degree here? 2. What's the lead coefficient? Pi. And what type is this? The degree's 2. That'll tell you what we call it. Quadratic. That's what we did all last chapter. Good. For lead coefficient, I would just write pi. We all know pi is the same thing as 3.14. Either way, you're fine. What are your questions on these? Again, if you get stuck, just go back to that chart, especially on the type. It might take you a little while to memorize those. Questions? All right, here's the next thing I want to look at. This is the method called direct substitution. Direct substitution is the type of substitution you have been doing forever. You are going to go through and you're going to replace every x with what they tell you x equals. So if you have f of x equals 2x to the fourth minus 8x squared plus 5x minus 7, and x is 2, you're going to rewrite this, and you're going to replace every x with a 2. If you wanted to replace this x with a 2 as well, that would be fine to say that this is f of 2, which means it's the f function evaluated at 2. If you leave it f of x, that's fine as well. Now, we just evaluate. What's 2 to the fourth? 2 times 2 times 2 times 2? Yep, 16. 2 squared is 4. So you evaluate your exponents first. Then you multiply. So do 2 times 16 minus 8 times 4 plus 5 times 2 minus 7. You should end up here. I'm assuming you guys can do multiplication. Then you do 32 minus 32 plus 10 minus 7, and you get 3. So direct substitution means just plug it in. Do the math. The main mistake here is order of operation stuff. Some people want to say 2 times 2 and then to the fourth power. Remember, in the order of operations, exponents come before multiplying. So do 2 to the fourth and then multiply that by 2. What are your questions? All right, here's another example of direct substitution. So f of x equals 5x to the third plus x squared minus 4x plus 1. I want to evaluate this when x equals 4. How do I do it? Plug it in. Good. Just waiting for someone to say it. So we are just going to rewrite or replace all the x's with 4s. What's the next step? This is where people go wrong. The what? The exponents, right? You need to do 4 to the third and 4 squared. That gives you 64 for the 4 to the third, 16 for the 4 squared. And then it's just multiplying. And then it's just adding. You all have calculators, so I'm assuming you can simplify this. You should get 321. What are your questions on direct substitution? Now, I'm going to be honest with you guys. Anytime I do substitution, I do direct substitution. It's the easiest way. It's the way you're most familiar with. However, there is another form of substitution. It's called synthetic substitution. There is a paragraph in your book that explains synthetic substitution, followed by an example. It's actually probably easier to follow along in the book than up here because I was trying to make it in general. So if you want to copy that down, you can. But you are not going to be required to use synthetic substitution. If you want to use direct substitution the entire time, that's fine with me. The directions will say synthetic substitution on your homework. Ignore the directions and use direct substitution if you want. So I'm telling you right now, this method is completely optional, but it's kind of neat, so I'm going to show it to you guys anyway. We'll only probably look at 2 examples. Again, just because it's optional, not a requirement, but kind of a neat thing to look at. So when you're doing synthetic substitution, the first thing you want to do is you want to write the value of x in a box. So we're going to have a number in a box off to the left. That's the number we're plugging in for x. We're going to follow it by all the coefficients of our function when we're written in standard form. The next thing you want to do, you want to bring down the first coefficient, multiply it by the x value in the box. You write that result in the next column. So below the next coefficient, you would write the answer you get when you multiply the first coefficient times the number in the box. Then you add it to that coefficient, bring it down, and repeat the process. That sounds like a lot. Once you see it, it'll make a little bit more sense, but that is the method for synthetic substitution. Like I said, this is just kind of a fun trick, is the way I think about it. Kind of cool. But again, you could use direct substitution every time if you do not like this method. So the first time we do it, I just want you guys to watch. I don't even want you to write it down because it's kind of takes a while to get it. So the first thing you want to do, you want to write the x value in a box. Then you want to write the coefficients following it. Make sure you're in standard form. And make sure you don't skip any. Like if this went from x to the third to x, you would need an x squared term with a 0 as the coefficient. So we want to drop down a 1, a 5, a 4, and a 6. Okay. Everybody still with me? The next thing you want to do, bring down your lead coefficient. The lead coefficient is 1, so I'm going to bring it down. I multiply that number by 2, and then I write it in the next column. Then you add those 2 numbers, bring it down, multiply that number by 2, write it in the next column. Add those, bring it down, multiply by 2, write it in the next column. Add those, bring it down. Don't multiply by 2. The last step, you do not multiply by what you plugged in. That's our answer. Now, if you plug 2 in everywhere and do the math, you will get the exact same answer. So you might say, well, why would I even do this? That's why I said you don't have to do this. You can use direct substitution. This is just kind of a cool way that also works. If the directions tell you one way to do it, you can ignore those directions. Okay? But I thought this was kind of a neat party trick. So here's our next example. I am going to use synthetic substitution. Like I said, if you want to use direct substitution, be my guest. Before we can use synthetic substitution, it has to be in standard form. So I'm going to write an x to the 4th term in the front, followed by my x to the 3rd term, followed by my x squared term, followed by the x term. Plus 0, because you want the coefficient there as well. Sorry, you want the constant there as well. You want each term to be represented. What goes in the box?
1.
What you're plugging in for x goes in the box. So now in our box we have a -3, and then you write the lead coefficients. So we have a 1, a 2, a 5, a -1, and then 0. So write all the coefficients starting with the lead coefficient, and you even include the constant. Do you remember what the first step is? Not quite. You got to drop the 1 down first. Then you multiply by -3. That gives you -3. You write it under the next coefficient. What do you do with these two? Add them. That would give you -1. Multiply by the -3. Positive 3 goes to your 5. 5 plus 3 is 8. 8 times -3 is -24. -1 plus -24 is -25 times -3, 75. 75 plus 0 is 75. Do not multiply by the -3. That's the biggest mistake here. People want to multiply by the -3 on the last step. You don't have to. Just stop. Questions on that? All right, I want to show you guys one where some terms are missing. I'm going to do this one kind of quick, so I wouldn't write it down, but I just want you to see how it works if there are terms missing. So when I write this one in standard form, I have -x to the 5th plus 0x to the 4th plus x to the 3rd plus 0x squared plus 0x plus 3. Do you guys see how they have to put those zeros in there? You need placeholders. If there's no x to the 4th term, you make one. What number goes in the box? -1. Good. Then each coefficient lines up after it. So you have the -1, 0, 1, 0, 0, 3. Like I said, I'll do this one kind of quickly. -1, you drop it down, you multiply it by our -1 in the box, you get 1. 0 plus 1 is 1. Multiply it by our number in the box, you get a -1. 1 plus -1 is 0. Multiply by -1, you still get 0. Add it to 0, you still get 0. Multiply by -1, you still get 0. Add it to 0, you still get 0. Multiply by -1, you still get 0. But we got to add that 3, so our final answer is 3. What are your questions? So your homework today is listed on your green sheet. It's also up on the board. I want you to be aware of this problem. Shh, almost done. This is what you should be able to do till tonight. Anything past 45 we have not discussed, we will get to tomorrow. So if you're working on this tonight, get up to number 45. The rest we will finish tomorrow. Questions? Remember, if it says synthetic and you want to do direct every time, that's fine. If you want to do synthetic every time and it says direct, that's fine. You get to pick the method.